Okay, so this was the second problem that we could look at. We want to do this graphically, but we're also going to write equations. And before we do anything, remember, we have to draw a free body diagram and find reactions, because they have to be included. So I'm going to draw a free body diagram, and this is the free body diagram I'm using for reactions. Remember, we have to use different ones as we're finding internals. And I have 5 kips going up, kind of right here. I have 15 kips going up. I have a little applied moment, 25 kip feet. I have by, bx, observation, I can see it's 0. I have dy. I have 10 kips over here. And I can see that I have this uniform load. Okay, so we're going to go ahead. This is 3 feet, and this is 5 feet. And this from here to here is 8 feet, and from here to here is 12 feet. So we have 3 and 5, and I'm going to simplify. So we can do that by finding the area under the curve. That's all we're doing. My base is 12 plus 8 is 20, and my height is 2, so I have 40 kips. I also know if it's 8 plus 12, which is 20, that half of that is 10, so it's going to be kind of right in here. So I have 40 kips that are going down, and I've got 15 kips up, 10 down here, 10 down here, and this distance is 10, and this distance over is 10. Okay, so now we don't have to look at that anymore, so we can start by summing forces in the x direction, and I can see that bx equals 0. Okay, and then we can sum moments about b, and again, you can sum it anywhere you want. Right now we want to get rid of one of our unknowns, so we can sum it at b, or we could sum it at d. So I'm going to put my finger at b. I'm summing the moment there, and you know, if you need to still like hold your pen, push down, you can see the rotation is a positive rotation. So I have 5 kips times 5 feet. Okay, I'm summing it here. Okay, that applied moment, positive 25 kip feet. Again, it already has units of force and distance. It is a moment. I don't need to do anything else with it. Okay, I'm pinned. I'm pushing up. I can see that that's positive rotation, so I have plus 15 kips times 8. And then I have minus 40 kips times 10. Okay, plus dy times 8 plus 12 is 20. Minus 10 times, okay, so we've got 22 minus, where's that a 3? 23. And all of this equals 0. Okay, so I'm going to keep my dy, 20 dy on one side, and I'm going to take everything else to the other. Okay, so we're going to do that in our calculator. So I have 5 enter 5 times, and right now it's positive, we haven't moved it, plus 25, okay, plus 15 enter 8 times, that's positive. Then we have this 40 times 10, okay, which is negative, so I'm going to put a negative on it before I add it. And then I have this negative 10, okay, times 23. And I'm going to add those together. And then remember, I'm taking it to the other side, so I'm now going to change the sign. And I'm going to divide by 20. Well, that equals 460. So dy equals, divide by 20, and I get 23 kips, positive value, so it must be going up. Okay, now I could either sum moments about d, and I could calculate by, okay, or I can sum forces in the y direction. Or I could do both of them and make sure that I have a correct answer. So we're going to start with summing forces in the y. I have a negative 5, okay, plus by, plus 15, minus 40, plus 23, minus 10 equals 0. And this is one of the reasons I try to put numbers back on my free body diagram so I don't forget anything. Okay, this is positive. We're going to isolate this one. Everything else moves over. So let's start with 5 change signs. Enter negative. then we have a 15 plus, we have a 40 minus, we have a 23 plus, and we have a 10 minus. And I have negative 17, but I've got to take it over algebraically. So I have by equals 17 kips up, positive value, okay? And if we got a negative, it just means we're pulling down, and that can happen. I mean, think about a barn with wind coming in. There's all that uplift. If you think something like that, and all this wind blowing through the big doors, okay, we are pushing actually up. So we might need to have straps that are holding it back down. Okay, so I'm just going to do in my calculator, I'm going to make sure that we have the right reactions. So I'm going to take my moments about, it doesn't matter, we'll take them right around here. That way everything is set up. So if I'm taking it at this point, the 5 goes away. So I have a by, which is 17, enter 5 times, that's positive, okay? I have a 25, which is positive. I have a 15, enter, and it's going to be 15 back times positive. I have a 40, enter, and it's going to be, I did the wrong thing on there, didn't I? So let's try this again. by is 17, 5 times, positive, 25 plus, 15, enter, and that 15 is 8 plus 5 is 13, 13 times, plus, then I have 40, it's going to cause a negative, and we were 10 over, that's the 15 times, plus, and then I have the 23 kips, okay, and it's going to be 25 times plus, and then I've got this 10 kips way over here, and it is at 28 times, and it is going negatively plus. So I did just a quick check on my math to make sure my everything was correct before I move forwards. So now when I come over here, I can put on this, I can say by is 17 kips up, and here I have 23 kips up, so I have everything on here. Now, if I wanted to set this up graphically, we can do that, but the first thing we're going to do is set it up by equations. So again, you're going to take your handy dandy post-it note, and everywhere that you see like a change in loading as you're moving across, you're going to have to make sure that you know that that's where you need to write your equation. So I'm coming across, okay. Oh, I changed, I have a reaction, and I've got this uniform load. Oh, I'm changing a moment and a shear. Oh, I added that. And so I'm going to have quite a few segments on this beam that I'm going to have to set up for equations. So you need to make sure, you know, if you need to have something, use your calculator, whatever, cover up everything. Start from the left, cover up everything that's beyond that. So our first free body diagram, we're going to go from 0 to x to 5, and it's going to have this 5 kips coming down, and then there's nothing going on here. X starts over here at the end, so I have an x because we're somewhere between 0 and 5, okay? And I could have internal normal, shear, and moment. And again, these are all drawn positive sign convention, beam, sign convention, okay? All of them are positive. And it's in terms of x. And here's what you need to do is just cover that up, because you don't want to see any of those other things and think you need to add it. You don't. So we can sum our forces in the x direction, and we can get that our normal force is 0. We can sum forces in the y direction, and I get a -5 minus v equals 0. Okay, so over here, this is positive beam notation. I have to draw it positively. When I use my rule, for equilibrium, I'm calling up positive. This has nothing, this is not behavior related. Not behavior related, okay? It's mathematical. So I have to make sure that I call this a negative v. So positive behavior is giving me a negative b in equilibrium because of my rule for equilibrium, okay? So I'm going to pull this over. So my shear is -5 kips. So anywhere I am between 0 and 5, I have -5 kips. I can sum my moments, and I am just kind of like a rule follower. There's my little point that I'm going to take my moments around, and I'm going to start at the left again. Okay, that 5, if I'm pinning it, 5 could cause rotation like a clock handle, and it's positive rotation, so I have 5 kips times x. Okay, and I'm coming across. Those are at my cut, but I do have that internal resisting moment equals 0, and they're both causing that counterclockwise rotation. So my moment equals negative 5x kip feet. Okay, so my loading is, I don't have any loading in here. I have this point load, nothing changes. So I have a constant. I have a 0 degree. And when I integrate a constant, I end up with a first degree curve. So mathematically, this is looking correct. And now I'm going to go from x from 5 to, so I'm going to go back to my picture. And I'm starting here, 5, okay, 5 plus 8 equals 13. Remember, our x always starts back at the very far left side. So again, I can take my calculator if I'm taking a test. I can take whatever. I can take my ID, and I'm going to cover up everything to the left. So my free body diagram has to look like this. So as I come across, I have 5 kips coming down. I have that reaction, which was 17 kips going up. I know that x goes all the way to the cut. I know that this little value right here is 5 feet. So this distance has to be x minus 5. Okay. I know I have an internal normal, shear, and bending moment, possibly. And I can see that I have this uniform load. I'm slowly adding it on. It has a slope, if you will, of 2 kips per feet. It's constant. And if I needed to find the centroid, because I will for my moment arm, okay, I know that the area of this curve is base times height, so I have x minus 5 times 2. And its moment arm has to be x minus 5 divided by 2 back, okay? So I have everything on my picture now defined. I have the point load, my reaction, I have this uniform load. I went ahead and found the area under that so I could make it a point load, and the point load slowly moves across. Okay, this distance is x minus 5. X starts way back here at 0. And so now we can sum forces in the x direction, and I get that internal normal is 0. Okay, I can sum forces in the y direction. I'm calling up positive. I have a negative 5 plus 17 minus, okay, area under the curve is 2 times base x minus 5 minus 2 times x minus 5. Okay, and then I have minus my shear equals 0. So we're going to isolate him. This, so we have negative 5 plus 17, so we're at 12, minus 2x, okay, plus 10. So we get 22 minus 2x kips. And that's my shear equation, okay? So if I come up here, I'm at negative 5. So let's just think about this. We're at negative 5. When I come here, x is 5. 2 times 5 is, what is 2 times 5? 10. Okay. Is this right? This doesn't seem quite right. So we have negative 5 plus, is that a 17? Yes, plus 17 minus 2. Minus 2 times, all of this is x minus 5. Okay, so I'm going to have negative 15 plus 17 is 12 minus 2x plus 10, which is 22 minus 2x. Okay. So here, if we put in x equals 5 for our shear, we're at negative 5 right here at that reaction, right here. And now if I put in 5, that's where I'm starting with this. 5 times 2 is 10. I should have that it pops up 17. It'll work out. I'm not worried. Okay. So, let's keep moving. Let's sum our moments about the cut equals 0. And if we sum our moments about this cut, we have 5 times x, okay, minus 17 times x minus 5, plus area under the curve is 2 times x minus 5 times its moment arm, x minus 5 over 2, okay, plus moment equals 0. So let's isolate. We're going to keep by himself, equals negative 5x plus 17 x minus 5 minus 2 times x minus 5 times 1/2 times x minus 5, and we get negative 5x plus 17x minus 17 in our 5, oops, 5 times 85 minus 85, okay, minus, well, those go away, so I have x times x is x squared minus 10x plus 25, so we get negative 5x plus 17x minus 85 minus x squared plus 10x minus 25. And so we're going to have negative x squared. And then we have 10 minus 5 is 5. Plus 17 is 22 plus 22x. Okay, getting these taken care of. Okay, see, getting that taken care of. And then we have minus 85 and minus 25. So we have minus 0, 10, 11. So this is our moment equation. This mess right here is our moment equation when we're going from 5 to 13. Okay? So we could organize these if we wanted to. We could have from 0 to x to 5. And I could say that my shear is negative 5 and my moment is negative 5x. And then we have from 5 to x to 13. And I have a shear equals 22 minus 2x. And my moment equals negative x squared plus 22x minus 110. Okay, and then when we're graphing these, we can plug in these values, and I can quickly see, oh gosh, look at that. You know, if I'm looking at my shear, okay, if I'm looking at my shear, which is in kips, okay, then if I'm at 0, I have negative 5. Okay, if I'm at 5, I still have a negative 5. And we'll be able to graph this as we go across. Now, some of you may be saying, well, why can't I just integrate and integrate? Because that seems to be what I'm getting. Well, it kind of is. If you look at here, if I integrate 22, I get 22x. If I integrate negative 2x, I get negative x squared. But see this negative 110? If you integrate, you have to keep up with that you have boundary conditions from somewhere. You have to figure out, well, how do I find my boundary conditions that I need to add back into that? So honestly, what we need you to do on the exams in here, when you take your exam, is you're going to have to just write all of these. You can't just integrate, even if you've kind of figured it out. But the nice thing is if you've figured out how to integrate, then you can check your answers, okay? So now we're coming across, and we have another change. And so I have, okay, 5 kips, I have 17 kips, I have 5 feet, okay, I have 15 kips going up, I have an applied moment of 25, I have more uniform load that's at 2. When I look at x, okay, we've got to come past that because we've cut it somewhere over here. So there's my beam. X goes all the way to the cut from the left. Okay, if this is 5 and this is 8, then this piece right here has to be x minus 13. Okay, I also know, I'm going to erase this too, that the area under my curve is, okay, is base times height. Area equals base times height. And we're going to continue this over Okay, but we're going to call this an area, and then we're going to call this one an area. So base times height is 2. So I have 16. And I know that 16, if this is 8, we are at 4 feet, 4 feet, 5 feet. So we have 5 plus 4 plus 4, and then 5 plus 4 plus 4 is 13. So this piece that's coming off somewhere cut in here is x minus 13. And I have normal, and I have shear, and I have moment. And here we are going from x. So we are 13x. And if we come across, we can see we're going to go 13 plus 12 equals 25. So 13 to 25 feet is what we're working with. Okay. So if I put a 13 in here, then yes, I'm at 13 feet here. If I put a 25 minus 13, it should come back to where I am the whole distance across. So we're just getting more complicated, but you just go slowly left to right. Let some forces in the x direction, and our normal is 0. Okay. So now let some forces in the y direction up. We forgot to label this. So this is base. Its base is x minus 13. Its height is 2. And if I know where that moment arm it's going to be, it's got to be x minus 13 divided by 2. Okay? So if we're going up positive, I have a negative 5 plus 17 minus 16 plus 15 minus base times height at minus 13 times 2 minus shear equals 0. Take shear over, so I get negative 5 plus 17 minus 16 plus 15, okay, minus 2x plus 26 equals v. And we're going to take our handy dandy calculator out here, and we have 5, change sign, enter, 17 plus 16 minus 15 plus 26 plus and I get 37 minus 2x equals my shear. Okay? And again, if this is a 0 constant, this has to be a first degree curve. So we're going to check it really fast again. 5, enter, 17 minus 16 plus 15 minus, and then we have 2 times 13 is negative, so 26 plus, let's make sure we have this, negative 5 plus 17 minus 16 plus 15, and then it's going to be minus x minus 13, 26, so positive 26. I just like to check everything 3 or 4 times. Okay, so there's my equation. So our moment equation is going to be incredibly long, okay, because look at all these things that are going to be multiplied by a moment arm. So let's sum our moments about the cut equals 0, and here's my cut. Here's my internal moment. We're going to start at the left. So I have a 5, positive 5 times moment arm of x, okay, minus 17 times, okay, it's not all of x, it's x minus 5, okay, plus 16 times, well, it's not all of it, but it's going to be x minus 13 plus 4, x minus 13 plus 4, okay, plus 25, okay, minus 15 times x minus 13, plus x minus 13 times 2 times x minus 13 divided by 2, plus that internal moment equals 0. So this is where it's algebra time. So everything's going to change signs as we bring it over because we're isolating m. So I have negative 5x plus 17 times x minus 5, which is not correct. X, and then when we come back, that's right, x minus 5. Okay, plus minus 16 times x minus 3 plus 4, so minus 9. X minus 9 plus 25. We're changing signs on everything, aren't we? Minus 5x plus 17 minus 16 minus 25 plus 15 times x minus 13 minus 2 times x minus 13 times x minus 13 times 1/2. So those go away. It always works out magical. Equals, here we go, minus 5x plus 17x minus 17, enter 5 times, minus 85 minus 16x plus 16, enter 19, that's not a 19, 9 times, so plus 144 minus 25 plus 15x minus 15, enter 13 times, minus 195. Okay, those went away, so minus x squared, and then we have minus 13x plus minus 13x, so that would be negative 26x, but with the negative plus 26x, and then we have plus 169, but minus 169 equals 0. So we can always pull this one out first, minus x squared. And then I've got, okay, a negative 5x, a 17x, a negative 16x, a 15x, and a 26x. So I have plus 37x, and now we're going to go through and we have 85, change signs, enter, 144 plus, 25 minus, 195 minus, 169 minus 330 equals n. I'm hoping this is right because I haven't worked this problem before, so I'm really hoping. So again, this is my moment equation from 13 to x to 25. Okay, so then to keep continuing on, you would have to then come and do another moment equation where you draw your free body diagram. So now we have from 25 to x to 25, 28. This time we have pretty much the whole thing. So we've got 5 kips, we've got 17 kips, we've got 15 kips, we have our moment of 25, we have a reaction here of 23. Okay, and we know that we have all of this internal, so our base is 20 because we have all of that now, and our height, we have 40. Okay, and I know if this is all 20, this has to be 10 feet back, and I think I drew it on the wrong side, and yeah, because this is 12 feet back. Okay, so here's 10 feet, and we said it was 20 times 2 is 40. So this is 10 feet back. This is 12 feet back. This is 20 feet back. This is 5 feet back. X goes all the way over to the end of my cut because we've got to come over X. So we have internal shear and moment. And if this whole thing is X, okay, if the whole thing is X, then we have to subtract off this 25. So this is X minus 25. So when X is 25 at 0, we're right there at the nub. 20, if we add 3, we should be 28, which is the length of our beam. And you're going to set it up the same way. -5 plus 17 plus 15 minus 40 plus 23 minus v equals 0. Take the v over, v equals moment. 5 times x, 17 times, and you just start measuring x minus 5, 15 times x minus 8 plus 5, x minus 13, and you come all the way across.